Hello everyone and welcome back to the final part of our tutorial series on the development of an AI-based crop disease detection system using CNN and TensorFlow. In our previous tutorials, we covered Part 1, Introduction and System Overview, Part 2, How the AI System Works, Part 3, the CNN and TensorFlow architecture. Part 4, dataset preparation and model training. In Part 4, we successfully trained our convolutional neural network and achieved a validation accuracy of approximately 87%. Today, we will evaluate the performance of our trained model, analyze the results, and discuss how the system can be deployed for real-world agricultural applications. So let's begin. We have successfully completed the development of an AI-based crop disease detection system using CNN and TensorFlow. Throughout this tutorial series, we learned AI fundamentals, crop disease detection concepts, CNN architecture, TensorFlow implementation, dataset preparation, model training, testing and evaluation, model deployment. Our final model achieved approximately 87% validation accuracy and demonstrated strong performance in identifying multiple crop diseases from leaf images. Our final model achieved approximately 87% validation accuracy and demonstrated strong performance in identifying multiple crop diseases from leaf images. This project provides a solid foundation for future research in artificial intelligence, smart agriculture, precision farming, and automated crop monitoring systems. Thank you for watching this tutorial series. If you found this tutorial helpful, please like, share, and subscribe for more tutorials on artificial intelligence, machine learning, deep learning, research development, and emerging technologies. See you in the next project. Again, this is Applied Intelligence, where intelligence is applied, not just learned.